Get the worksheet used in this lesson, as well as hundreds of others, at Mathcation.com. This video is about our rational and irrational numbers worksheet. You can get the worksheet we use in this video for free by clicking on the link in the description below. Before we do a couple practice problems on our rational and irrational numbers worksheet, I want to go over what exactly a rational number is and what exactly an irrational number is. Now, a rational number is any number that you can write as a ratio of two numbers. In other words, any number that you can write as a fraction. The first type of rational numbers are whole numbers. The reason whole numbers are rational is because every whole number can be written as a fraction. For example, if we have the whole number of 6, all whole numbers technically have this 1 underneath of them because it's like saying 6 divided by 1. We typically do not write this 1 because obviously 6 divided by 1 is just 6, so you do not have to write it. It doesn't change the number. So when you see a whole number, it doesn't matter what the whole number is, there is a divided by 1 or a fraction of 1 underneath of it. The second type of rational number are terminating decimals. Now, a terminating decimal is any decimal that stops or ends. So if you look at 1.75, this clearly has an end point. It's right here after the 5. You can write this as a fraction because you can rewrite 1.75 as a mixed number. So it would be 1 and 75 over 100, which would be the unsimplified version, but it just proves that you can write it as a fraction. The third type of rational numbers are repeating decimals. Most commonly you will see 0.3 repeating, which is 1/3, or 0.6 repeating, which would be 2/3. It's any decimal that repeats the same pattern over and over again. Irrational numbers are numbers that cannot be written as fractions. The easiest way to remember what an irrational number is that it's any non-repeating and non-terminating decimal. The most common examples of irrational numbers are pi, because it goes on forever, and unless a square root is a perfect square, it will be an irrational number. You can see that both of these decimals do not follow a pattern, and the dots indicate that they go on forever, so they never end. Moving on to some practice problems on our rational and irrational numbers worksheet. Now, the directions for this part of the worksheet just say to identify whether it's a rational number or an irrational number. Number 3 gives us -8, which is a whole number. Now we know -8 can be rewritten as -8 over 1, and -8 over 1 is a fraction, which means it is rational. Number 4 gives us the cube root of 64. In order to simplify this, we have to find what number times what number times what number equals 64. In this case, that number is 4. So because it's 4 times 4 times 4, 4 is a whole number, which means the cube root of 64 is rational. Number 8 gives us 4 times the square root of 2. Now we already know that the square root of 2 is an irrational number. This is equal to 1.4142, and it goes on forever. When you multiply 4 times the square root of 2, you will get 5.6568, and it goes on forever. Our decimal never repeats, and because of the dots, it means it goes on forever. That means this will be an irrational number. The square root of 77 is not a perfect square, and when you do the square root of 77 in a calculator, you get 8.77496 that goes on forever. This is neither repeating or terminating, so it's non-repeating, non-terminating, which means it is irrational. If you found this video helpful, make sure you drop a like. Subscribe to our channel or check out our website for more premium math content. Thanks for watching.